Hey everyone, and welcome to this explainer on what is, without a doubt, one of humanity's greatest scientific journeys, our epic quest to explore the red planet. I am absolutely thrilled to guide you through this today, because Mars isn't just another rock floating in space, it's really a mirror reflecting our own planet's history and potentially a window right into our future.
Are we alone? It's the grand, overarching mystery of our existence. Every piece of metal we've ever hurled toward Mars, every single line of code written for a rover, and all those sleepless nights scientists have spent agonizing over data, it kind of all boils down to this one profound question. The entire history of Mars exploration is completely framed by our relentless search for an answer to whether life exists or ever existed beyond our homeworld.
Okay, let's dive right into this. Here is our flight plan for today. We'll be covering 1. Why the red planet, 2. How we explore Mars, 3. Historic milestones and missions, 4. Major scientific discoveries, 5. The challenges of exploration, and 6. Humanity's Martian future.
So, Section 1, why the red planet?
To really understand our absolute obsession with Mars, you have to think of it not just as a destination, but as a massive planetary laboratory. It's a place that can actually help us figure out Earth's past and, quite possibly, our future. What's wild is how familiar some of these features sound. I mean, Mars has seasons. It's got polar ice caps, volcanoes, and undeniable evidence that liquid water once flowed right across its surface. Because of these incredible Earth-like similarities, Mars is our absolute best candidate for finding past or present life. Our objectives there are pretty straightforward. Search for those signs of life, decode its water history, figure out how the whole planet evolved, and ultimately prepare for human missions. Those similarities, they are our literal call to adventure. Moving on to Section 2, how we explore Mars. Knowing why we want to go, well, that's only half the battle. The other half is the mind-blowing, incredibly complex technology we've developed to actually uncover the planet's deeply held secrets. We basically use 4 distinct tools of discovery out there in the cosmos. First up, flybys. These are spacecraft that literally zoom past the planet, grabbing rapid-fire data and images. Next, orbiters. These stick around a while, revolving around Mars to map the surface and track weather patterns. Then we have landers, which actually touch down on the alien surface to perform really highly complex, stationary experiments. And finally, the rock stars, the rovers. These are our mobile robots that traverse the treacherous terrain, analyzing rocks and soil just like remote geologists. It's brilliant. All right, Section 3, historic milestones and missions. Looking back at the timeline of our attempts to reach out and touch Mars, you really have to appreciate how brutal the early days of the 1960s and 70s were. I mean, humanity pushed through over 40 initial mission failures, over 40. But look at the rapid progression once we finally figured it out. In 1965, we got our very first close-up images from a flyby. By 1971, we managed to tame the orbital mechanics and achieve the first Mars orbit. And then, 1976. That's when we actually stuck the landing, with the Viking missions becoming the first successful landers to send back detailed surface images and run life detection experiments. That early momentum paved the way for an absolute dream team of robotic heroes. Seriously, these machines are legends. We've got NASA's Pathfinder from '97, an underdog mission that gave us the very first rover, Sojourner, proving low-cost exploration was actually doable. Then came the unbelievable endurance of Spirit and Opportunity. I mean, Opportunity traveled over 40 kilometers across the Martian surface. Today, Curiosity is out there finding organics, and Perseverance is actively bagging up samples while hunting for ancient microbial life. But hey, it's not just a NASA story. The European Space Agency has been a total powerhouse, with Mars Express finding subsurface water. And we absolutely cannot forget India's ISRO. Their Mongolian orbiter was an incredible first-try success that operated for 8 years, massively exceeding everyone's expectations. Which brings us to Section 4, Major Scientific Discoveries. So let's transition from the magnificent machines themselves to the actual groundbreaking paradigm-shifting secrets they dug up from the dirt. Through these missions, we've completely unveiled a new Mars. We found undeniable evidence of dry riverbeds and confirmed massive deposits of underground ice. Basically, Mars was once wet. Even more tantalizing, the Curiosity rover found organic molecules, the essential building blocks we need for life studies. We've detected mysterious methane spikes, a gas often tied to life on Earth. And we've mapped out vast polar ice caps made of water and CO2 ice. Every single one of these massive discoveries regarding water and organics just continuously ties right back to our ultimate search for life.
And geographically speaking, Mars operates on a totally alien scale that just builds absolute awe. It is home to Olympus Mons, officially the largest volcano in the entire solar system. It completely dwarfs anything we have here on Earth. And as if that wasn't enough, it boasts Valles Marineris, a giant canyon system that would stretch all the way across the United States. The topography alone is just staggering. Let's pivot to Section 5, the challenges of exploration. All these scientific victories are glorious for sure, but they're incredibly hard-won due to the brutal realities of the Martian environment. To really grasp the challenge, you have to understand the distance. Roughly 225 million kilometers. That is the jaw-dropping distance a spacecraft has traveled just to get there. It's an unfathomable void to cross, and it demands absolute precision from our engineers. And because of that immense distance, we run into this massive roadblock, 24. That represents up to 24 agonizing minutes of communication delay. Think about that for a second. If a rover is hurtling toward the surface and runs into trouble, it takes up to 24 minutes for that signal to even reach Earth. By the time we hear about it, the event is already over. Spacecraft are entirely on their own, relying strictly on pre-programmed instructions during the most critical life-or-death maneuvers. And let's say they do survive the landing. They immediately face relentless environmental hazards. We're talking about extreme, hardware-shattering cold temperatures. We're talking massive global dust storms that can literally swallow the entire planet, blocking out the sun and completely killing the solar power these machines need to survive. This is exactly why the historical mission failure rate is so incredibly high. So many brave robotic explorers have met their doom in the Martian dust purely because of these harsh conditions. Finally, Section 6, Humanity's Martian Future. All the struggles, all the crashed probes, all the triumphant rovers, they are all paving the way for the ultimate boon, humanity finally stepping foot on the red planet. The scientific community has a pretty logical progression mapped out for our next giant leaps. Step 1 is happening right now and in the near future, executing robotic sample return missions. We desperately need to bring pristine Martian soil back to Earth's labs. Step 2 involves taking everything we've learned from these robotic tests to ensure human survival, targeting the launch of actual crewed missions, likely in the 2030s. And Step 3 is the ultimate sci-fi dream turned reality, establishing ongoing, self-sustaining Mars colonies. I think this quote from our source material really hits the nail on the head. Mars exploration represents one of humanity's greatest scientific journeys. We have to remember that this isn't just about rocks and rovers. This is about our prep work for interplanetary life. It's about advancing our technology and engineering in ways that benefit us right here on Earth, while at the exact same time inspiring a whole new generation of scientists and explorers to look up at the night sky and dream bigger. In driving all of this is astrobiology, the study of life beyond Earth. This one vital scientific discipline is basically the key to unlocking our next era of existence in the solar system. Every single time an orbiter scans the atmosphere or a lander drills into the ice, we are pushing the boundaries of astrobiology further than ever before. So, we began this explainer with a question, and we're going to end with one. When you consider the water we've found, the organics we've detected, and the sheer, stubborn human ingenuity it takes to land robots millions of miles away, will Mars become the next frontier for human civilization? The robots have definitely paved the way. The next footprints in that red dust, well, they just might be ours. Thank you so much for joining me on this explainer. Keep your eyes on the stars and stay curious.